Okay, so you need to pull out the sheets that we worked on in the first video, and this will be the rest of the material to help you get you through your wow. So what I want to do is I just want to look at some notation, and then we'll look at some examples, and then you can conquer your wow. And I'll make 2 other videos after this. So a set, which is what this section is on, is just a collection of objects. And typically, if we're listing the objects, they have these kind of squiggle brackets. And the names of sets are usually capital letters like A. We looked at C when we did the candy, and S and R for round and red. So it's just capital letters. And when you're going to list the elements in a set, you use this, I call this set notation, to let the viewer know that you're describing a set of objects. Now there are 4 symbols that are in the homeworks that we need to get down. The first one is a subset of and is not a subset of. So a subset is a set that is part of some other set. Okay? So when you use either of these, and we'll talk about proper subsets in class, but the important thing is whenever you're using either of these 2 symbols, you're dealing with sets. Okay? So for example, if I listed the set, which I have written below on a sheet of paper, the collection of elements consisting of 1, 2, 3, and 4, and I said, is this set a subset of n? And you would say yes. That 1 and 2, every member of 1 and 2 is also a member of n, so you would use the set notation. But if I said, is the set consisting of the elements 3 and 5 a subset of n, you would say, well, is every element of the first set a member of the second set? And you would say no, and that the no part is that slash that says 3 and 5 is not a subset of n. So this means every element of the first set is also in the second set, and this says every element in the first set is not a member of the second set. Okay? So these are the first 2 pieces of information. Second 2 pieces that you have to get down are is a member of and is not a member of. Or you'll hear me say is an element of and is not an element of. So for these, we're just dealing with individual pieces. So you are dealing with one member or piece of a set. So for example, let's look at the difference between this and this. Since you have the squiggle bars, this is the defining a set containing the element 1. Since we're dealing with set notation, we're going to use this and say, yes, every member of this set is also a member of how I defined n. So this subset is a subset of n. Do you see that there's no squiggles here? This is just saying one individual piece of information. So is this number 1 an element of or a member of n? And yeah, it is. Right here's n and there's the number 1. So 1 is a member of n. Okay, and just to contrast it, if we did this, so is 5 a subset of n? So we'd use the subset notation and say, no, it's not. And then this, since there's no squiggles here, we're just talking about an element or a member. And 5 is not a member of the set N. Okay? So those are the 4 symbols. So let's go ahead and turn to the first organizing of the Venn diagram we did. So I'm on the front of the last page, and I just made up some problems. Okay? So if you're using this symbol or this symbol, you're dealing with sets. So they're going to be capital letters or something that has that notation in it. If you have the E, oh, I have a cat coming towards me, which means an element of or not an element of, that's if you're dealing with just members or individual pieces of a set. Oh dear. Told you this is going to be one take. That was Leo. Of a set. Okay. So let's practice some of these. You ready? All right. So the sets are defined up on the top, and I can look at this. Here's my A, here's my B, and here's my C. So let's try this one first. So I see the squiggle, so I know I'm going to be dealing with sets, the set notation, one of these two. So is every member of this set also a member of A? So is 4 and 6, are those both pieces that belong to A? It looks like they are. So I'm going to say that this is a subset of this. Now, I'm looking at B, and I see that 6 is, but not 4. So the set containing the elements 4 and 6 is not a subset of B. All right? So for this one, I see the squiggle bracket, so I know I'm dealing with a set notation. So is 6, is this subset that has the element 6, is this set that has the element 6 a subset of B? Is every member of this also a member of this? Yep. But you see how this one doesn't have the squiggles around it? So this is just talking about a single piece of information. This is an element or a member. And 6 is an element or a member of B. All right? So I'm dealing with set notation because of the squiggles. So this is the set containing the element 4. Is every member in this also in B? You say no, 4 doesn't belong in B. So this is not a subset of. But this one, do you see how there's no squiggles around it? So this is purely an element. And so since that piece 4 is not in B, we're going to say 4 is not an element of B. All right, now just like inequality symbols, where the mouth has to open up to the larger value, this is the same with set notation, that the only direction we have is this. So the bigger one always has to be on the right. So is every member of A a member of U? Yes. So this set A is a subset of U because every member of A is in U. Remember the big piece, this is going to eat the bigger set. So this has to go, the big set has to go on the right. So, but I'm just telling you the flip does not exist. So this is the only direction the sign goes. So again, we're comparing two sets. Is every member of U also in A? Nope, because U is much bigger. So that's how I know that U is not a subset of A. All right, we're going to be doing some flipping. So find that single sheet. We organize the data for this one. And then on the back, I want you to try it. Pause and see if you can do A through F. Okay? Pause the video and then see if you can do A through F, and then we'll finish talking about the front page of the 1.2 sheet. So give it a pause and give it a try. All right, so the A, B, and C are defined on the previous page. So let's look at C. Now this is set notation, right? Do you see this is a set and this is a set because of the squiggles. So I know my only two choices are this or this. So let's flip back. Are 3 and 6 a member of C? Yep. So every member of this first set is also a member of that set. So we've got subset of. Okay, let's look at this one. So there's not, I don't see any squiggles, right? There's no squiggles. So we've got an element or not an element of. Okay? Right? Because that's not a, this is not a set. It's just a piece. So if you flip back, you'll see that 3 is in C. So this would be an element of. All right, now there's no squiggles here. So I know my only two choices are this or this. So is 2 a member of B? Yep, it sure is. Okay, so 2 is an element of B. Now this is a set. We've got a set. So we're going to be either using this or this. And since 2, every member of this set is also in this set, then we're going to use our subset notation. Okay. All right, let's repeat for C. You ready? So there's no squiggles. So I'm either using this symbol or this symbol, right? This is just an element of. If I flip back and I look at C, I can see that 2 is not in there. So 2 is not a member of or is not an element of C. And then here we're comparing sets, right? That's a set and that's a set. So I'm going to use this symbol or this symbol. And just like we just looked, 2 is not a member of C. So every element in this set does not belong in this set. So that would be not a subset of. So those are on the homework. You shouldn't have any problems with those now. And then the only other thing I want to cover on this video, I'm trying to make them shorter so you'll stay with them. I just want to look at the other little bit of notation on here. So when we start talking about the intersections of sets, we're going to be talking about common elements. And if sets don't intersect, then they don't have anything in common. And so if we're dealing with subsets with intersections, this notation means that the set is empty. There's nothing in it. And we'll talk about this more when we do intersections and unions, but that is also the same notation, and that means a set with no elements in it. All right. Equal sets should make a lot of sense. Equal sets mean they are exactly equal. So here I'll make a set. I'll call one F and I'll call G. And if you make them equal, this one's going to have a 5 and a 10 in it. If they're equal, then this also has to have exactly a 5 and a 10 in it. It's what you would think. So F equals G. And then the last symbol are what are called equivalent. See the little, it's called a little tilde. And so equivalent sets are sets that contain the exact same number of elements. So they don't have to have the exact same elements, but they have to have the same number of elements. So this set contains the letters M-A-T-H. This set contains the numbers 1, 2, 3, 4. So there's a 1-to-1 correspondence between each member of those sets. So M is equivalent to N. And that purely means that these sets have the same elements, same number of elements. Okay, so that should be enough to get your oh wow done. I'm gonna make 2 other short videos that talk about describing sets, and then we need to get into set notation. And then, so there'll be 2 more videos coming. They're hopefully a little short. And so then when we come in after our long 2 weeks of not seeing each other, we can jump right in with both feet. All right, 2 more coming.